Good day, I'm Chelsi Cabral and I will be discussing the first part of compression molding. So the overview of this presentation, we will start with the introduction, materials of the process, tooling or machine, process, product, advantages and disadvantages, and conclusion. Introduction. Compression molding is the process of molding in which a preheated polymer is placed into an open heated mold cavity. The mold is then closed with a top plug and compressed in order to have the material contact all areas of the mold. Compression molding is generally used for thermosetting plastics. Let us now discuss compression molding's history. Alfred Critchlow founded the Pro Molding Corporation in Florence, Massachusetts in 1847. Pro is thought to be the very first plastics molding company to be established in the United States. The very first plastic products included items such as buttons, brush, and mirror handles that were compression molded, which are relatively small and had relatively simple geometries. In 1909, Leo Hendrik Baekeland found thermosetting compound, the phenol formaldehyde resins. Patents on automatic compression machines date back to 1930. Over the years, compression molding press capacities or sizes increased so that larger thermoplastic and thermoset plastic parts such as radio housing could be molded. So here are historical pictures of compression molding. So this is a handmade mold for handheld mirror from 1870. Trimming flash from Echo Radio cabinets 1934. And the large-scale compression molding press from 1935. What are the materials used in this process? So we have three materials, the thermosetting polymers, fiber-reinforced plastics, and the thermoplastics. Thermosetting polymer. A thermosetting polymer, which is also known as a thermoset or thermosetting plastic, is a polymer consisting of cross-linked structure or heavily branched molecules. The properties of thermosetting polymers. One of the main properties of thermoset plastics or polymers is that they harden during the molding process and after solidifying, they cannot be softened. Typically, when the polymers are molded and shaped, they acquire a three-dimensional cross-linked structure along with the strong covalent bonds that further help them retain their strength as well as the structure even if the temperatures are set high. However, thermoset plastics are brittle and tend to char and burn if heat is applied for a prolonged state. Normally, thermosets decompose before melting. Meanwhile, thermoset resins are insoluble in most of the inorganic solvents. Fiber-reinforced plastic. Fiber-reinforced plastic, FRP, is also known as fiber-reinforced polymer. It is a composite material made of a polymer matrix reinforced with fibers. The fibers are usually glass, carbon, basalt, or aramid, although other fibers such as paper or wood or asbestos have been sometimes used. Properties of FRP. These composite materials typically exhibit low weight and high strength. They are so strong that the automotive industry is increasingly interested in using them to replace some of the metal in cars. Fiber-reinforced plastics can be as strong as some metals, but they are much lighter and therefore more fuel efficient. Fiber-reinforced polymers typically have impressive electrical and compression properties and display high-grade environmental resistance. One important factor that makes these materials a favorite among different industrial sectors is the manufacturing process, which is quite cost-effective. The rate of productivity is medium to high, and the ready bonding is exhibited with the similar materials. The other exclusive properties of fiber-reinforced plastics include commendable thermal insulation, structural integrity, and fire hardness along with UV radiation stability and resistance to chemicals and other corrosive materials. The last material is the thermoplastic. A thermoplastic is a material, usually a plastic polymer, which becomes more soft when heated and hard when cooled. Thermoplastic materials can be cooled and heated several times without any change in their chemical or mechanical properties. This is the property of thermoplastics. Thermoplastics have a simple molecular structure comprising chemically independent macromolecules. Upon heating, they are softened or melted, then shaped, formed, welded, and solidified when cooled. Multiple cycles of heating and cooling can be repeated, allowing reprocessing and recycling.
Hi, I'm Jeremiah Dioso, and I will be reporting about tooling, machines, and their processes. Okay, let's start. First, compression mold presses are manufactured in a wide variety of sizes. Second, most presses utilize a hydraulic ram in order to produce sufficient force during the molding operation. Third, the tools consist of a male mold plunger and a female mold. This is the parts of the compression molding machine, and this is the varieties of the machine. This is the press, and this is the mold. There are two types of compression molding. First one is the sheet molding compound, which is the SMC. Second is the bulk molding compound, which is BMC. Now I will explain about the sheet molding compound. As with other thermosets, SMC is a mixture of polymer resin, inert fillers, fiber reinforcement, catalyst, pigments, stabilizers, release agents, and thickeners. Manufacturing of SMC is a continuous inline process. This is the example of SMC manufacturing process, as the figure shows. Second, bulk molding compound. BMC is available in bulk bags as well as slab form. The mixing operation can be done in a number of ways. Premix employs three methods for combining glass with paste. First is the continuous screw mixer. Second is a sigma blade mixer and a blow blade mixer. The figure shows about. Next is the process. The compression molding starts with an allotted amount of plastic or gelation placed over or inserted into a mold. Afterwards, the material is heated to a pliable state and by the mold. Shortly thereafter, the hydraulic press compresses the pliable plastic against the mold, resulting in a perfectly molded piece, retaining the shape of the inside surface of the mold. After the hydraulic press releases, an injector pin at the bottom of the mold quickly ejects the finished piece out of the mold, and then the process is finished. Process sequence. Loading a precise amount of molding compound called the charge into the bottom half of a heated mold. Second, bringing the mold halves together to compress the charge, forcing it to flow and conform to the shape of the cavity. Heating the charge by means of the hot mold to polymerize and cure the material into a solidified part. Opening the mold halves and removing the part from the cavity. And this is the exact presentation of the process. And this is the other part.
Hi, I'm Mr. Bendana and I'll be presenting the products, advantages, and disadvantages of compression molding. Now for the products, compression molding is used for manufacturing electrical parts, dinnerware, and gears. It's also used to produce buttons, buckles, knobs, handles, appliance housing, radio cases, and large containers. It's also used for several more applications. In automotive parts, it's used to make hoods, bumpers, fenders, and spoilers. In the medical field, it is used to make caps and plugs for blood separation machines and ultrasound equipment. For aerospace, compression molding is used to make electrical connectors to guided missiles. Now, for the advantages of compression molding, the first one it is cost efficient, and then it is also suitable for high volume production. Compression molding is capable of producing large components and is efficient in material usage, meaning the waste materials is very minimal. The process is physically quick and efficient with a low number of process steps. It is also capable of producing detailed features such as holes, which with other molding techniques would need additional machine to deliver. For the disadvantages, the first one is that it requires large curing time. Present also are uneven parting lines, and the scrap materials cannot be processed again. There are no delicate pieces, and it requires high initial investment. Also, secondary operations are needed after the molding, like trimming. The mold depth is limited, and there would be product inconsistencies. In conclusion, compression molding efficiently delivers high volumes of components economically. With the drive towards more fuel-efficient hybrid power technology and lower production costs, then we are likely to see some significant ways of using the technique. The almost daily development of exotic materials and the increased refinement of the press machinery and processes, the future is surely one of continued growth. That would be the end of our presentation. Thank you.